we are talking about another graph that is called the line graph, and that establishes a relation in the form of a line between the values on the x-axis of a graph and the values on the y-axis, and the relationship is shown in the form of a line and is easier to understand. As an example, we are considering a survey made with mothers who have to remind their teenagers to do their chores, and we are interested in knowing how many times they have to remind their teenagers to do their chores in a week. So table 2.7 shows two columns. In the first column is given the number of times a teenager is reminded. In the second column, this is the frequency of mother's response. So we see that two mothers don't have to remind their teenagers to do their chores. 5 mothers think that they have to remind their teenagers once a week. 8 mothers think that they have to remind 2 times, and 14 mothers think that they have to remind their teenagers 3 times in a week to do their chores, and so on. So we plot a graph between these two variables. So first column is supposed to be the x variable, and the second column is supposed to be the y variable, and we see that on the axis we plot the numbers 0 through to the number 5. Actually, we take it to number 6 to make it more convenient. And in the second column, the values are ranging from 2 to 14. So minimum value is 2 and the maximum value is 14. So we pick the values between 2 and 14, and we label the graph from 0 up to a few numbers ahead of 14. So we stopped at 16. Okay, now we see how we draw the graph. So we see that the number 0 on the x-axis corresponds to number 2 on the y-axis. So we connect 0 and 2, and we draw an imaginary line, a vertical line at point 0, and an imaginary horizontal line at point 2, and their intersection will be the first point on the line graph that is shown as the square, and this means that this is connecting the point 0 with point 2. The second point connects between point 1 and point 5, I guess. Let's go back to the columns and see, yes, point 1 connects number point 5, and that we can see as the second point on the line graph. Similarly, the third point must show the connection of point 2 with point 8, and we see that the third point is showing the connection of point 2 on the x-axis with the point 8 on the y-axis. Now, can you please take a minute and see if all the connections are made correctly? And you need to pause the video for that purpose. Okay, so now you have seen how the line graph is made. So after we locate all the points, connecting the points on x-axis and the y-axis, we just join all the points to see how the graph is working and it is displayed. And we see on this line graph that most of the responses of mothers about the reminders to their teenagers lie between 1 and 4, you can see, because that's where the graph is growing most of the time. And the point connecting between 0 and 2 and the point connecting 5 and 4 seems to be a bit outlier, because if we draw an imaginary line in the middle of the graph, or where it has the maximum points, where is the peak of the graph, so if we draw an imaginary line, then most of the points that lie on that imaginary line are on the right and on the left, and they are near between points 1 and 4 on the x-axis. So the line graph really helps us to understand where the most of the data lies on the average, and which points can be considered as outliers, which are a bit far from the center, far from the mean of the graph, we can say. So line graph is really important, and you should listen to it again and again to understand how it works. So you have the first example of the line graph. Actually, it's the second example. So 39 people were asked how many times in a year they have their car in the shop for repairs. And the table shows that the number of people who never appeared to repair their car were 5. And it was about a certain shop. We have no concern about the shop. We only concern about the data about the shop, that how many times people appear to repair their cars. So we see that there are 5 people who never appear in a year to repair their car, and 9 people appear once, 16 people appear twice, and 9 people appear 3 times. And we look at the line graphs of this information. Now in the first option, we see that the graph has on the x-axis the number of times in a shop, which is the left column in the table, so this is correct, and the right column is frequency, which is along the y-axis, so the graph has the correct axis taken. Okay, now regarding the information, we see that the 0 number of times stands for 5 people, so this is correct. And the graph shows that the number of people who appear once were 9, which is correct, and the number of people who appear twice were 16. So 2 goes with 16, yes, this is also correct, and 3 goes with 9. So this first graph looks correct to me, and since there is only one correct answer, I will pick it without going further and see how did I do, and my answer is correct. Next we are talking about bar graphs, which is another form of representing a two-dimensional data. So sometimes we just don't want to use the line graph and we prefer to look at the bar graph for the same data. Now the only difference between line graph and bar graph is that bar graph can also be represented in a three-dimensional system. So sometimes we use a two-dimensional system, or sometimes we use a three-dimensional system if we have 2 types of informations given for a variable which we plot on the x-axis. For example, in this example, we have information about Facebook users, and the information is about the age groups and the number of Facebook users and the proportion of Facebook users for that particular age group. So there are 3 groups that we can see here, and if we plot the bar graphs here, then the ages come on the horizontal line, the x-axis. So there are 3 groups of ages, so we enter the groups from 13 to 25, and then 26 to 44, and 45 to 64, and then their proportion is given on the left hand side. All these options are available on Excel and many other statistical softwares, but Excel is the basic one and represents a variety of options to plot line graphs and bar graphs. Now bar graphs can also be horizontal, so you can represent the ages on the left side along the vertical side and proportions along the horizontal side if you want to look at the horizontal bar graph. But this is how we generally use. So in this graph we are only considering the ages and proportion and not the number of users. So it's a two-dimensional graph. Here is another example of the bar graph in which the column has its the table has its first column about the race or ethnicity of people in the second and the third column. People in the second column are examinees and the third column are students. So we see that Asian American or Pacific Islander people have 10.3% examinees and 5.7% students in that particular organization. Similarly, 9% of the same organization are Black or African American, and 14.7% of students are Black or African American. So you can note all the other ethnic origin people who are either examinees or students. And we represent this information in the bar graph, taking on the x-axis the race or ethnicity, and on the y-axis the percentage of examinees only, not the students. Okay, So in the first bar graph, we represent the population of that is represented by a number that is assigned to that population, and that number is 1, and it represents Asian American or Pacific Islander people. Why we do that? Because we are using information in mathematics on a bar graph. So it is easier to label the x-axis in numbers, but Excel has an option to label in words as well. So you can write this in words if you feel comfortable with it. However, I prefer to write it in numbers. So I have assigned numbers to each group, and number 1 represents Asians or Asian Americans or Pacific Islanders, and we see that there are 10.3% examiners. So if we plot the percentage on the y-axis, then 10.3 goes to number 1. Similarly, number 2 is represented by number 9, which means that the group representing number 2, which is Black or African American ethnicity, has 9% examinees. Similarly, 17% of examinees belong to Hispanic or Latino, which is represented by number 3. So 3 goes to 17, and you can associate all of the numbers according to the data and see how the graph is represented. You're given a table about the population of a city that is made up of children, working age adults, and retirees. This is table 2.10, and it shows the 3 age groups which are divided into ages as children with 13 to 25 years of age, working age adults with 26 to 44 years of age, and retirees as 45 to 64 years of age. The number of people in each age group is given in column 2, and the proportion of population of each age group is given in column 3 of table 2.10. We have to identify the correct bar graph that represents this information. And for that, we just keep in mind and try to remember, just to save time, that children are 18% in the population, working age adults are 44%, and retirees are 38%. Now with this information, if we draw a graph between the age groups and the proportion of population, then the bar corresponding to children would be the smallest bar, and the bar consisting of the working age adults should be the longest bar, while the third bar should be in between the first two. So let's go to the choices and see which one represents the correct graph. Okay, the first choice seems to be wrong straight away because the first bar is the longest bar. Okay, the second case is the same. In the third case, the first bar is the smallest bar, but the last bar is the longest bar instead of the middle bar. So we skip this choice as well. Okay, the fourth choice seems to be a good choice. And the fifth choice again is the wrong choice because the smallest bar is the last bar. Okay, so obviously the fourth choice is the correct choice, and we see that the population of children which are 13 to 25 is about 18%. The population of working adults between 26 and 44 is 44%, and 45 to 64-year-old people which are retirees are about 36 or 37%, which is from the table we can say that this is 38%. Yes, it is closest to 38%. All right, so it seems like we have chosen the right choice, and now we see if we have done it correctly. Okay, so the system has turned it green, which means that we had been right in our choice. We are considering another example of a city in which we will be discussing about voters of the city. So the city has been divided into 6 districts, as you can see in the table. And in all these 6 districts, there is a registered voter population in each district, and there is an overall city population of each district. So we see that District 1 has 12.5% registered voter population. I am looking at column 2, which is the voter population, and similarly in District 2 there are 11.2% voter population, and similarly we can move on to the 6th district and see that the population, voter population is different in each district. Now, to identify the correct bar graph of this population, we can set some variables to notice, which will help us reduce our time of making a decision. So, for example, I can see that the minimum voter population stays in the 3rd district, and the maximum voter population is in the 6th district. So I must be looking at a bar graph where the 3rd bar is the smallest bar and the 6th bar is the largest bar. So we move on to our choices and see what happens. So we have to look at 3 as the smallest bar, 6 as the largest bar. So can number 1, first option be the right option? Obviously no. So we move on to the second choice, and again we see that 3rd choice is not the smallest choice. In the 3rd option, bar 3 is the smallest bar and bar 6 is not the largest bar, so we move on. The next population again shows that 3 is not the smallest bar. The last option has 3 as the smallest bar and 6th bar as the longest bar. So this must be our answer. So we pick this one and then we check how did we do.